the things that many artists I talk to seem to struggle a little bit with, not because it is hard work or anything, but just because to many it feels really tedious, is the setup part of a project, the bit that takes place before any of the creative work gets going. This means that many of us either skip this phase altogether, basically making up folders and folder structures as we go, or we skip through it so quickly that we miss some real opportunities to speed up the production process for ourselves as we get further on down the pipeline. Which in part is why I'm really looking forward to working through this course with you and hopefully helping speed up your day-to-day projects, freeing up time that you can then spend enhancing your Unreal creations. We will do this by essentially creating two Unreal template projects. The first one being an outdoor template that features both a physical sun and sky system and an easy to access HDRI workflow, one that we can then just drag and drop our FBX or Datasmith mesh files into. We will also in this template be setting up a working folder structure to help organize our scene or level, as well as looking at how we can create a playable character that will allow the end user to walk around our visualization project. On top of this, we will also construct a master material that has exposed parameters, a material that can then be used again and again inside our projects by simply creating child materials from it. Add some good quality light mask settings to the mix and we will be good to go. Next, we will focus on creating a product shot template, seeing how we can quickly import data, set up a flexible 3-point area lighting system, as well as add multiple cameras and a level sequence that will give us control of those cameras in a variety of ways, which would include animating the camera to help show off the product. Now, even though you can feel free to use the basic templates that we create here for your own production work, or maybe just a variation of them, the real point and purpose of this course is to show how easy it can be in Unreal to shave big chunks of time off the start of a project, simply by thinking about the typical needs of the projects we work on and then creating a startup template for them. Let's dive in then to creating the first of our two startup templates inside the Unreal Engine. In order to take a look at adding all of the template features or items that we are going to want to run through in this course, we naturally need to take a step back now and start at the very beginning by creating a blank project into which we can then place them, one that we can quickly and easily build on as we progress through this training material. Now, I am going to be assuming here that you have already installed and set up all of the software required for the course, which would include both the Epic Launcher and Unreal Engine 4.26.2, or whichever version you have chosen to work with. So if you haven't done that already, can I suggest that this would be a good time to nip over to the unrealengine.com website and make use of the big blue download button found there in order to get things sorted out in that department. Once we have done that, and with the Epic Launcher open, we can now fire up the Unreal Engine version that we are wanting to work with, and straight away we should be confronted with the Unreal Project Browser, this being the point from which we can either open up an existing project or start a new one based on one of the template types provided, which in this instance is exactly what we are going to do by selecting the Architecture, Engineering and Construction option and then hitting the Next button. Having chosen the category, the next window that we come to gives us the ability to create a template that is a bit more focused as regards the type of projects that we may typically be working on. So we have an Arch Viz template, a HoloLens setup, and we even have a collaborative type template. As you may have guessed though, what we're going to be choosing here is the blank option, simply because this is the easiest from which to create the more customized setup that we want. Now do feel free to select one of the other options found here if you already know that it sets up features that you will want to use on projects of your own. After hitting the Next button, we can choose to add some starter content if we like, so placeable meshes along with basic materials and textures, Or we can, as I will do, elect to add nothing at all to the scene. I am also going to keep things running as fast as possible inside the engine by leaving the real-time ray tracing feature off as well. Finally, for this exercise, we can choose where on disk, network, or in the cloud our project will be saved to, which in my case will be the Unreal Projects folder that can be found inside the exercise files download that I have placed on my desktop. And we can also add a project name with template_01 being my preference. And with that, we can hit the Create Project button. One final thing that I want to do here before we go ahead and move on to our next exercise is add a few pieces of test geometry to the scene that can help us with the setup of a few basic engine options. These of course can be deleted once the template setup is complete. And so from the geometry section of the Place Actors tab, let's drop a spiral staircase into the scene, setting it at 0, 0, 0. And then, after hitting the F key to frame up on the selected geometry, let's also add some objects to the base of the steps. And then, after tweaking the positioning to suit, we can select the floor and hit F again to frame up our view, save the project, and then move on to the next part of our exercise. Having set up our base project in the introduction chapter, we are ready to start building the kind of template or templates that we will likely want to use on our day-to-day work projects. It being perfectly feasible, of course, to have a variety of starting templates from which to choose if we regularly, either as a freelancer or as a studio, work on a variety of project types. From inside the Unreal Content Browser then, after having dismissed the new plugins message if needed, the very first thing that I will want to do here is make certain that the Sources panel over on the left-hand side of the UI is open, given that it can help save quite a bit of time when navigating through a project's folder structure, simply because we don't have to travel backwards and forwards through the breadcrumb trail in order to navigate the hierarchies that we may have set up. Now, hopefully, it does go without saying here that folder and asset naming on a project are hugely important, with each individual or studio needing to work out what they either want or need to use as a consistent set of naming conventions on their projects. So that we have something to work with here, let's go ahead and right-click in the Content Browser panel and create a new top-level folder that we will call Blueprint. Although one thing that we may want to do here, if already familiar with Unreal, is use an abbreviated folder name such as BP in this instance, mainly because the total length of the file path allowed for any assets inside an Unreal project, including the asset's name, is limited to just 260 characters, a requirement that can potentially cause all kinds of problems for us should we ignore it. We have had blueprints simply stop working because of this limitation, even though the node structure or coding within the blueprint itself was entirely sound, so do be warned. Let's also do a quick bit of color coding here by right-clicking on the content folder itself first of all, and choosing the Set Color option, after which we can pick, let's say, a nice golden hue of around about 0.5, 0.28, and 0 in the red, green, and blue channels. After which we can do the same for our Blueprints folder, setting it to a blue color of around about 0.045, 0.13, and 0.86. Again, these values being in the red, green, and blue channels. A pretty obvious and yet essential tip here being that if we take the time to create a standard color legend that is then used for all of our in-house Unreal work, we will probably find that both ourselves and any other artists who use that system will be able to very quickly navigate through a project's folder structure without oftentimes having to read the folder labels, thus potentially speeding up our workflow no end. Let's next create a few extra folders inside the content folder whilst we are here, so that we have 8 in total. We can title them Maps, for putting our level maps into, Materials, for material creation, SK mesh for skeletal meshes if we use any, ST mesh for all of our static mesh models, sound for any sound cues that we may need to import, camsec for any camera sequences that we use, and then finally we can add a UI folder for any user interface elements that we may need to create. Again, we can add some color coding to the mix, which I will leave up to your discretion, though just for reference, this is the color set that I have used in my level, so do feel free to copy this if you like. Now, of course, if you are following along here with a view to creating an actual template project for use in production, do feel free to add whatever alternative or extra folders you feel you may need. As you can see though, setting up an easy-to-use folder structure, especially so when making use of the source panel on the left of the UI, can potentially be a massive time saver for any artist starting work on a brand new project, with the color coding that we have also set up helping us easily identify and then navigate through our folder structure. Even the standardized naming conventions that we have chosen, once we get used to them, can help us in a whole bunch of ways. Hopefully, it does go without saying though that we will of course need to make certain that all in our team, and indeed any freelancers who may be drafted into work on our projects, all understand the folder structure, naming conventions, and color coding being used in our template so that there can be unity and harmony in the workplace. The default Arch Viz template in Unreal, the one that we have just used as a starting point for our own project template, does, as you will have noticed, come with a fully functional sun and sky system already set up and ready to work with. And just to show that this is the case, after selecting it in the World Outliner, let's swing our viewport around so that we can clearly see the sun sitting in its physical sky environment. And if we then alter the latitude and longitude values of the system to about the 83 and -40 mark, we get a nice golden hour type glow in the viewport. Now, dependent upon which version of the engine you are using, if you were creating a project template from scratch in Unreal, rather than using the blank architectural option to start with as we have, then even after dragging a sun and sky system into the level from the light section of the Place Actors tab, you may not see the control options that we are using here. If that is the case, then you will probably need to open up the Plugins browser from the Edit menu, and then search for and enable the Sun Position Calculator plugin, which will of course require a restart of the editor should you need to enable it from there. Once everything is working though, we can change the time zone that our project is set in if need be. We can alter both the month and the day being shown if we like. And we can of course use the current solar time option in order to ensure that we are looking at a very specific time of day. The solar time control using floating point values in military style notation in order to do this. Do also keep in mind that if we twirl down the advanced date and time settings, we are also currently using daylight saving in the scene as well, which will affect the look of the lighting that we see. Now, one of the things that we may wonder about at this point is whether or not we can have separate control over each of the individual lighting elements found in this sun and sky system. Well, it is worth noting that with any blueprint actor selected in the World Outliner, we will also see the separate components making up that system listed under the Scene twirl down, though we may need to adjust our UI a little in order to be able to see that properly, depending on our screen real estate. If we click on, say, the directional light listed then, what we get access to is all of the typical directional light options that we may already be familiar with the same being true of the skylight part of the system as well. Which means, of course, that we potentially have a huge amount of artistic control available to us when using this default daylighting setup. Especially so once we factor in the power of the sky atmosphere actor that we also have in the template, which can itself be tweaked to recreate all kinds of atmospheric conditions as it interacts with the sun and sky lights. What if we want or need to have a different set of lighting options available to us for creating daylight in a scene though? For instance, one staple of Arch Viz creation, and one that we may want to include in our custom template, is the use of specific high dynamic range images to provide both scene lighting and to be used as a visual backdrop, which is exactly what we will go ahead and set up now. Rather than deleting the existing sun and sky system out of the template though, let's instead select each of the lights found in there and turn off the Effects World option for it in the Details tab. Which means that, besides currently having a completely blacked out scene of course, we can now build a template in which we are able to easily swap between the physical sun and sky system that we have and an image-based lighting one that we are about to build, as and when needed. When we're ready then, we can, from inside the Light section of the Place Actors tab, left-click and drag to place a HDRI backdrop actor into the scene, and then quickly use the location controls in the Details tab to set it at world coordinates of 0, 0, and -10. Why -10, you may ask? Well, because the HDRI backdrop actor features a ground plane option that can come in really handy for certain types of work, as it gives us the ability to quickly and easily place objects, such as a car being visualized for instance, into a real world setting that already has ground contact shadows set up. In this instance though, leaving it at 0 in the Z or Z axes would only conflict with the floor geometry that we already have in the scene, and so -10 seems like a sensible setting to use for now. Something else we can see is that we also have a default HDRI load up that instantly changes the look and feel of our scene. Of course, we could change the HDRI being used here if we needed to, but given that this is a template project, leaving as many Unreal-based defaults in place as possible may be a good idea, given that dependent assets such as this HDRI will always be available inside any installation of Unreal Engine on any computer system that we care to open our project from. Just to show how we could change this if we wanted to though, let's jump into the Materials folder inside the Content browser, and then after right-clicking in there, use the Import Asset command to grab the spruit_sunrise_8k.hdr file from the Extra Assets, HDRI Haven, and Sunset Sunrise folders, as found of course inside the exercise files download for this course. We will need to tweak things a little before using the HDRI, and so let's double click on the thumbnail in order to open it up in an editor window. And then in the LOD or level of detail section, set the image's MIPGen settings to no mipmaps, so that what we're getting is a nice crisp image, after which we can save and close the editor, given that Unreal will have already recognized this as a floating point image file. The final step that we need to take here, with the HDRI backdrop actor selected, being to drag and drop the HDRI file onto the cube map slot, which then instantly updates our viewport, though we would of course need to build our lighting at this point in order to see the full effect. If the perspective appears to be shifting somewhat in the image that we have loaded into the HDRI backdrop, which we are seeing happen a little bit here, we can adjust the Z or Z axis value in the projection center control in order to make things a little more visually pleasing, with a value of 600 seeming to work well here. And that is it really. We now have two daylighting options that we can choose from as a starting point in our template, with the Effects World switch in the Skylight component of the HDRI backdrop again being the way to switch this particular light setup off and on as needed. In terms of the types of projects that we as an individual or as a studio regularly work on, it is entirely possible that we have a signature style or look that we want to add to our template setup. Or it could alternatively be that we typically do lots of jobs that are very similar in terms of their general look and feel. Either way, setting up a post-process volume to suit those needs inside our template here will definitely help us get up and running each and every time we start a new project. One choice that we will need to make at this point though is what exactly we want to be handled via the post-process volume in our scene, and what should come down to both the lights and cameras that we use in terms of the mood and styling. As an example, let's take exposure in the scene. Should this be handled on a per camera basis, allowing for per camera flexibility when exposing our shots? Do we take a slightly more globalized approach and use post-process volumes to set exposure levels? Or do we in fact control scene brightness via our lights instead, rather than taking the more photographic exposure approach? Another example of styling choices that we could add to the mix here are visual effects such as bloom, lens dirt, ambient occlusion, to name just a few. Again, do we add these on a per camera or per post-process volume basis? Each choice bringing both pros and cons with it. Meaning we really need to make such choices based on the specific needs of the projects that we typically work on. For me personally, when creating a template such as this, handling effects like ambient occlusion on a per volume basis, rather than tying them to the light bake phase, means that I can add different levels of ambient occlusion to different areas of the scene simply by placing a different post-process volume in that location. Each of the volumes used can then have more unified effects such as bloom and colour grading added to them in order to give the project a more coherent feel. Having said that, effects such as lens dirt I prefer to add on a per camera basis, as I can then use the final position of the camera in the scene to help me decide how much or how little of an effect should show up in the shot. A camera placed very close to a water feature, for instance, in order to show it off, could possibly have some type of smearing or blurring added to the lens controls in order to simulate moisture condensing on the lens. Per camera lens effects would also mean that we can add different maps to each of the cameras if we wanted, thus giving the whole production a more dynamic and film-like feel, as opposed to having one generic look across all of the shots. All, as we say, project-based and artistic choices that we will need to make as we set up our template project. Taking a look in the World Outliner then, we do of course already have a post-process volume in the scene as provided by the default Unreal template, a post-process volume that we could make adjustments to at this point if we wanted, though we could also just create our own from scratch in order to ensure that all of the options found on it are set at default, thus building our template from as clean a foundation as possible. If that is what you would prefer, then all we need do is again come to the volume section of the Place Actors panel, scroll until we find the post-process volume entry, and then, using a simple left click and drag, we can place a new post-process volume into the scene. As an alternate approach, we could also just come to the Place Actors search field, begin typing the word post, and then select the post-process volume in that way. This approach working no matter which section of the Place Actors UI we are currently in. As I am happy to simply tweak the existing volume though, let's take a look first of all at the already mentioned ambient occlusion option, which can be found inside the rendering features section of the post-process volume controls, where we have an ambient occlusion rollout. We can also note that AO is enabled by default in Unreal's blank Arch Viz template. Let's focus our camera on the geometry that we have in the scene then, if it isn't already, by selecting one of the pieces and then hitting the F key to frame up. And if we then set the ambient occlusion radius to about 35 and alternate the intensity setting between 0 and 1, we should be able to clearly see the contribution that ambient occlusion is making here. Now, which default settings we ultimately decide to use for ambient occlusion in our template will again be very much dependent on the types of projects that we are creating. If this was a template for use with large-scale outdoor spaces, for instance, then we would probably want to use larger values than we would, say, for a Product Viz template where smaller numbers would likely be more useful for picking out smaller details in the scene. For now, though, I will just keep 05 and 35 as the defaults here. Which brings us back to the signature look or mood that we mentioned in the introduction to this exercise, given that the lens and colour grading rollouts that sit just above the rendering features here are where we would want to be in order to help create just such a look. The lens rollout handling some of the features already mentioned, such as exposure and lens masks, as well as depth of field, lens flares, and chromatic aberration. In the colour grading rollout, we have access to a wide range of grading tools that include white balance options, global colour grading, and even more granular control over the separated shadow, midtone, and highlight portions of a render. Now, in this instance, I'm going to leave everything set at the current neutral defaults, simply because a neutral template is possibly the most useful to have available, given that more specialized effects and grading can easily be added later on in the project, and also because those effects should probably be ultimately influenced by the final lighting design that is added to the project, which of course is not typically going to be set up in a starting template such as this. In fact, all that we have done to the lighting setup in our scene so far is create two different daylighting options for the template. And so let's save what we have created up to this point, if needed, and move on to taking a look at some of the lighting options that we may want to think about adding to our template setup. Assuming that we are going to be using light baking as a part of our visualization process, something else that we may want to add to our project template is a high quality light bake setup that can be easily controlled via the lighting specific options found in the drop down build menu. This letting us select from quality settings that range from preview at the low end and go all the way up to production. Setting something like this up in our template will hopefully mean that we will only need to make minor light bake adjustments on a per project basis during the production phase, rather than having to recreate a high quality light bake setup each and every time we start a new project. Coming to the World Settings tab in the Unreal UI then, which if not visible can be opened from the Windows menu. Let's make sure that we are first of all viewing our light mask controls, and then go ahead and reset all of them so that we are essentially able to start from scratch and build in the settings that we want. As we are using a daylight approach to lighting our scene, be that sun and sky or HDRI, probably the first thing that we will want to do here is make sure that we are getting light bounds in our environment, which means using the indirect lighting and sky lighting bounce options. Now, the indirect control handles light bounds from things like spotlights and the directional light that we are using as a sun in the sun and sky version of our setup. And so let's set a value of 2 here as a starting point. Simply because the visual impact on outdoor scenes when using light bounce values beyond this do start to reduce very quickly. Though once our project is complete and final lighting in place, it would probably be prudent to come back here in order to try out different values if we think that the scene could benefit. The settings used here having a different effect, of course, if we are developing an indoor as opposed to an outdoor project. For the sky lighting option, this naturally enough affecting the skylights being used in each of the daylight solutions in the template, we can again set a bounce value of 2, with emissive materials also being affected by this particular setting. The next controls that we will tweak are the indirect lighting and smoothness options, with these really needing to be adjusted in tandem, though they only become really useful or even necessary should we need to bring out finer details in our scene, such as when creating highly detailed interiors, for example. As a starting point though, I am going to recommend setting these to 1.1 and 0.9 respectively, seeing as for the final project we can incrementally adjust them as needed until the cost versus benefit ratio is set at optimum. Though I can honestly say that I have rarely needed to stray from this 1.1 and 0.9 setup for outdoor scenes, and indeed oftentimes the defaults of 1 and 1 will do just nicely. Another control that I would say rarely needs to be adjusted is static lighting scale. A good reason for not doing so, unless necessary, being the fact that this option can significantly increase light bake times without really adding too much in the way of a visual benefit to the scene. If we do have lots of little nooks and crannies in either an indoor or outdoor environment though, then we may want to lower this setting ever so slightly, though I would advise as light-handed an approach as possible when doing so. And with that, we have very quickly created a customized set of light build options, though again, you should feel free to use whichever light mask or other light build options you feel will best suit the template that you need. If you feel that you need to take a more in-depth look at Lightmask GI in Unreal though, you can of course take a look at my Unreal Engine Global Illumination for Architectural Visualization course as found here in the LinkedIn Learning Library. In the following exercise then, we will take a look at placing some default cameras into the scene that can be used for static shots, should we want or need to also create some high-res still renders from our visualization level. One of the big benefits of creating visualization projects inside Unreal is the fact that we can choose, based on a broad range of required delivery types, how our work will be presented to the end user. So we could, for instance, create a real-time walk around in Unreal, whereby the user can interact with their surroundings as if in a game environment. We may be working on an altered or virtual reality piece that gives users an even more immersive experience, or it could also be that we want to use a more photographic or cinematic type approach, and so are presenting the project via both still and animated camera shots, both of which will mean that the camera and sequence tools in Unreal will play a big part. As we will be showing you how to create a player start option for use in a real-time walk around in the next video, what we will focus on here is the setup for a photographic or cinematic approach. Coming to the cinematic section of the Place Actors panel then, we can click and drag to add a new cine camera to our level, which, while selected, gives us a preview of the slice of the environment that the camera is currently looking at, giving us the ability to very quickly move it into a position or view that we like. Over in the Details tab, again with the camera still selected, we can also set the camera's film back, focal length, aperture, and other controls so as to more closely mimic the type of real-world cameras that we might use if shooting real-world architecture. It could also, of course, be the case that real-world cameras have already been used on our project and we are required to match their basic characteristics here inside Unreal, this being the area in which we would do so. In fact, just so that we can make some changes here in order to see if they stick once we save our template project, I will set this camera to use a 16:9 DSLR film back, as that is what I would be shooting with out in the field, and also use a 24 to 70mm lens with a current focal length setting of 35mm. Now we can of course set up as many cameras as we would typically need on a per project basis here, but as we are next going to set up a default sequence in our template so that we can use an animated camera in our workflow if needed, I will stick to just the one camera for now for simplicity's sake. After jumping into the CamSec folder in the content browser then, let's right-click in some empty space, and from inside the animation flyout, choose the Level Sequence option. Now, I prefer to use this over the Template Camera option as it allows me to affect actors and settings in the level as the sequence plays. And so if I want doors to open, lights to turn on or off, colours of furniture to change, all of these can be done via this kind of sequence. I will very unimaginatively name this Sec01, and then with the camera still selected in the scene, you will see why in a moment, let's double click to enter the sequence editor. From the top of the UI, via the Track button, We can now add an actor to the sequence, and seeing as what we want here is a default camera that we can animate and work with right away in the template, we can, because we already have our camera selected, expand the Add Actor to Sequence menu, and right at the top we should see our scene camera, which we can now easily click to add. And as simply as that, we are now set up and ready to add any animation to our camera that we want, and then also run this sequence at any point inside a running level that we want. And whilst this may seem like quite a small or quick thing to set up inside a project, even if we didn't have it in the startup template, if we had to run through these steps, say 100 times in a month, with each iteration taking us about 5 minutes to complete, that would be over 8 hours a month spent on just setting up a default camera in the scene, rather than working on a project's creative aspects. Which does seem a waste, really, when adding a camera to our startup template is as easy as we have just seen. And again, if we regularly use multiple camera shots on a project, we can easily add as many cameras to this template as we like. So that is how we go about adding default cameras to a scene that can be used to create either photographic or cinematic shots. What if we also need our level to be playable though, so as to let the end user roam or walk around the visualization project? Well, setting up a playable camera is what we will look at next. As we have already noted, one of the most appealing aspects of using Unreal on a visualization project is the fact that we are able to give the end user complete access to all areas of the visualization subject, with this functionality perhaps being most appealing to those working in the Arch Viz and construction fields. This kind of setup also providing a jumping off point for us to then add extras to the project, such as various forms of interactivity, along with other immersive elements such as spatially reactive audio effects, for example. In order to create just a basic playable level though, the first thing that we will need to do here is create a player controller blueprint, which can be done by firstly jumping into our blueprint folder inside the content browser. And then after right-clicking in some empty space, we can select the Blueprint Class option from the Create Basic Asset list. In the Pick dialog that opens up, let's expand the All Classes rollout if needed. And then in the search field, start to type the word Player. After which we can select the Player Controller option that appears in the sorted list, and hit the Select button. Straight away, let's give this a name, so BP for blueprint, underscore P1 for player1, underscore CTRL for control, simply because this will be the player view that our blueprint will control. What we are essentially doing here in Unreal Speak is creating a link between a pawn, an actor in the level that the user can possess or take control of, and the user themselves. Setting things up this way, actually giving us more flexibility later on in the project, should we need it. Next, let's run through much the same process by again right-clicking in the content browser and adding a new blueprint class, only this time we want to choose the character option from the main list and call it BP underscore P1, as it denotes our blueprint player 1 character. Moving forward, we will again need to right-click in the blueprint folder in order to create a third new blueprint class. Only this time, when we come to the All Classes drop-down, we will want to search for the word Game, and then select the Game Mode Base option, calling it GM underscore Arch Viz once it has been added to the folder. We will want to add some tweaks to the blueprint setup here, and so let's double click on the GM underscore Arch Viz node to open it up. And then from inside the editor, we can set the player controller class to use the BP underscore P1 underscore control option that should show up in the list. And then also set the default pawn class to use the BP underscore P1 character. This meaning that both the controller and the player will now be used by this game mode. A game mode being a system that we use to essentially store the rules of the game or visualization. In our case, we are using it to simply tell the game to use both the controller and the character that we have just set up. The really nice thing here being that should we want to add more complex rules to our visualizations, then we now have the ability to do so. Our next step is to assign some axis mapping for the various types of motion that we want our player character to have access to. And so let's open up the project settings from the edit menu, and then in the input and axis mapping sections, left click on the plus icon in order to add a new axis mapping entry, which we can descriptively call move forward/backward. This essentially giving us the ability to move in both positive and negative directions along a given axis. In the drop down below, let's make certain that we first of all assign the W key from the keyboard section to the +1 scale, and then after clicking the plus icon to create a second entry, assign the S key to a -1 scale. As we will also want our controllable camera to be able to move to the left and right, let's create another new axis mapping entry, and then after creating two new input fields for it, assign the A and D keys to both the 1 and -1 scales. In this instance, I would also like the user to be able to look up and down using the mouse as well as be able to turn around. And so with a third mapping axis added called look up/down, we can assign the mouse Y motion to a -1 scale, and then use a fourth mapping with mouse X set to a +1 scale. These player inputs now allowing us to reference the controls in order to tell Blueprint what to do with the player controller once it is activated. In fact, depending on our controller preferences, we may need to swap which entries are using the positive and negative numbers here. If we then open up the Maps and Modes section of our preference editor, we can set the default game mode option to our GM_Arch Viz blueprint, which should in turn populate all of the fields in the selected game mode twirlout. As that is all we need to do with the preferences, we can close out the editor if we like, as we now want to open up the full blueprint editor for our BP_P1 node. After clearing everything out from inside the Event Graph tab, we can right-click and add a Get Control Rotation Pawn from the search list. After then left-click and dragging from its return value port, we can add both Get Forward Vector and Get Right Vector nodes. After which we can also right-click in the empty space on the graph and add both Input Axes Move Forward Backward and then Input Axes Move Left Right nodes. Dragging from the execution port of the forward backward node, let's search for and add an Add Movement Input node, and then pipe the forward vector into its world direction input, and the axes port on the Move Forward node to its scale input. After which we can do the same for the Move Left Right input. Let's also do a bit of house cleaning here by selecting all of the nodes currently sitting on the graph, and then adding a comment box around them by using the C key, which we can call Base Player Movement in order to clearly identify the function of the nodes found here. We can even colorize this if we like. And there we have it. We have now added basic player movement to our template and made it obvious what the controls are for. Though we haven't of course finished, as we also want the user to have the ability to look up, down and around in the level. And so let's right click in an empty portion of the graph and then add our Input Axes Look Around and Input Axes Look Up events. From the Input Look Around's execution port, let's click and drag to add a Add Controller Yaw input node, and then connect the Axes Values output to its val input, and then also create an Add Controller Pitch input to the Lookup event, and again connect the Axis Val output to the val input. Meaning we have now given our player camera or user the ability to look all around our scene using the mouse controls. Let's again add a comment box around the nodes, calling these Base Player Look, again giving them a colour, and then all that remains is to both compile and save what we have, and then back in the main editor window, test the level out using the play mode, which, as you can see, nicely adds the basic building blocks for having a person walk and look around our visualization piece. Do also keep in mind that all of the motion produced here can be edited and altered at any time by jumping into the character blueprint and selecting the character movement component. Depending on the types of projects that we are generally called on to create, one thing that we may consistently need in our levels is a basic outdoor environment into which our visualization pieces can sit. If that is the case for us, then having a basic terrain set up inside the default template could well prove useful. And so, coming to the Modes drop-down on our main toolbar, let's swap over to the Landscapes option, which immediately sets the Unreal UI up in a way that helps us focus on landscape or terrain creation. Before we go ahead and start that though, let's just pause for a moment or two and ask ourselves a few basic questions that can help determine what it is that we really need to be able to do here. So first of all, how would we describe the type of projects that we typically work on? Are they small to medium scale residential pieces in which we would probably be most interested in up close and detailed landscapes such as gardens and so on? Do we specialise in properties that sit in more rural locations? If so, then we will most likely want a slightly more extensive landscape with details that stretch further into the distance. Or do we work mostly on large-scale industrial-type complexes where the terrain is likely to be flatter and probably a little less detailed in terms of things like foliage? Having answers to these and other similar type questions readily available can really help us decide the type of default landscape or landscapes that need to be included in our template. To create something fairly basic for ourselves in this instance though, let's, in our landscape panel, set the section size option to the smallest available value, which is 7 by 7 quads. Which, as we can see, if I just pull back a little in the viewport and then hide the HDRI backdrop, gives us a much smaller section of landscape with which to work, though we do still have quite a bit of polygon detail available so that we can sculpt the terrain as needed. If we typically do large-scale visualizations though, perhaps having multiple buildings spread across a larger landscape, then we may want to stick with the default of 63 by 63 sections. If we want to either lower or increase the overall resolution of the terrain that we are using, we can do so by altering the number of components that we have, with higher values giving us a bigger overall resolution, whilst lower numbers, such as 2 by 2, give us a very small section of terrain indeed. Now at the moment we are looking in the viewport at a preview of a possible terrain, because in order to actually place the mesh into the level, we would need to use either the Create or Fill World buttons found at the bottom of the panel here, with Fill World expanding the boundaries of the landscape quite significantly. For demonstration purposes, the terrain preview that we can see here is more than good enough to work with, and so I am just going to hit the Create button and call that done. Though we could of course do a lot more here if we have some very specific terrain requirements, given that all of Unreal's terrain sculpting tools now become available to us. As many visualization projects are going to be set in a variety of locations though, this very basic terrain setup may be all that we need in terms of giving ourselves a head start on a project. One of the things that can potentially confuse a visualization artist coming to Unreal from something like a V-Ray or Corona and 3ds Max workflow is the way in which Unreal's material system works, with the concept of master and instanced or child materials being a little different perhaps than the setup that we are used to. And whilst explaining Unreal's material system is beyond the scope of this particular course, there are certainly courses in the LinkedIn Learning Library that can help if needed, such as Craig Barr's Unreal Introduction to Materials course and Joel Bradley's Unreal Engine Materials for Architectural Visualization. Suffice it to say for this course though that adding a few well-chosen, as in often used, master materials to our template would be a big help in terms of speeding up our overall production process. Of course, both the type and the number of master materials that we need is going to differ greatly from one artist or one studio to another. And so what we will do here is create a simple but reasonably versatile all-purpose material that can have its diffuse, normal and roughness maps swapped out at any time, and that can be made metallic or non-metallic as needed. So a basic PBR material essentially. Although we do also need to keep in mind the fact that we can add or take away as much functionality from this material as we feel our template will need. Coming to our materials folder as found inside the content folder, let's right click in some empty space and create a new material, calling it MST_mat for master material or something similar. After which we can double click to open it up for editing. Now the first thing that I will want to do here is right click on the graph area and then add a texture coordinate node, this allowing us to use any existing UVW mapping that may be found on the static mesh files that we bring into the level, thus giving us the ability to control texture map tiling very easily. This being Unreal's material system, we will of course need to build that tiling control for ourselves, and so we can next drag from the output port of the texture coord node and create a multiply node. After which we can hold down the 1 key and click to add a constant that will be the actual tiling control value. This we can set to a default of 1 and then pipe it into the B slot of the multiply node. Now just for housekeeping's sake, let's keep things tidy and organized here by selecting all of the nodes that we currently have and then hitting the C key to add a comment box, which we will name UV Tiling Control. Next, we will need to create the diffuse or base color controls, and so let's first of all right click in some empty space to add a texture sample node that will let the user add their own bitmaps to the material should they want or need to. After which we can pipe the UV multiply node into its UV input in order to use UV tiling should it be needed. To test this setup out, I have supplied a simple UV checker test map that I will add as the default here, though using a bitmap of your own choosing may possibly work better for you. To bring my default into the project, let's set our material editor window as a tab in the Unreal UI, and then from inside the materials folder in the content browser, right-click and import our UV test map into the project from the exercise files download. Back in the material editor, with the texture sample node selected, we can come to the texture slot and then search for and add the UV map that we just brought in. This in turn now showing up in the texture sample preview on the node. With the basics of a material in place, let's move on to our next exercise and take a look at how we can add some extra functionality to the diffuse space color channel if wanted, before we go ahead and connect it up to the material itself. Having started creating a generic and yet hopefully versatile master material for our startup template, what we want to take a look at next is how we might add a bit of extra functionality to the diffuse or base color channel before moving on to setting up the rest of the material's characteristics. To do this, let's, with the material open in the editor, hold down the 3 key and then click to automatically add a Vector 3 node, which we will be using to add a color tint over the diffuse or base color map if wanted. Now, I'm going to set a red value as the default here so that when the user turns the tint functionality on, they can see something very obvious happen. Whereas if we just leave this set to black, it could potentially look as if something has just gone wrong. Now, this is just a personal choice based on what I have observed. Dragging out from the Vector3 node, we can next search for and add a blend overlay node, which will do exactly what it says on the tin and overlay the tint color onto the texture map currently being used. Though we will need the blend rather than base port to be connected here. We also need to add some control over how this works, and so let's drag out from the blend overlay, add a static switch parameter, not function node, and then pipe the blend overlay into its true slot if needed. We can also make sure on the left of the UI that the default value for the switch is set to false, which it should be when created. This just meaning that the color tint has to be deliberately enabled by the user before it can be applied. After that, we can pipe the texture sample node into the false input on the switch, as well as into the base input on the overlay node. Finally, we can pipe the switch node into the base color slot on our material, and when we alter the default value now, we should see our tint color overlaid onto the UV test bitmap. We will again need to do some housekeeping, and so let's add a comment box to all of our diffuse nodes, and then call them base color with tint in order to match the material's own naming conventions. To continue building the rest of the material parameters that I want here, let's again hold down the 1 key on the keyboard and click to create a Vector1 node that we will then want to pipe into the metallic slot of the material. This giving us the ability to numerically set, using 1 and 0, whether or not the material is a metallic substance. Now, if you are getting a bit worried that all of these nodes are looking very unintuitive so far as their naming is concerned, don't worry, as we will be sorting that out in just a little while. Before that though, we next want to add 2 texture sample nodes for controlling both the roughness and normal slots on the material, given that these particular options will either often, as in the roughness, or always, as in the normals, be controlled by image maps. After duplicating our existing texture sample node twice using the Ctrl and W keys, we can connect them up to the roughness and normal map inputs on our material. And as we are unlikely to want to leave our UV test map set as the default here, let's select each node in turn and just clear that map out. Assuming that we will want to control UV tiling in our maps on a global rather than per map basis, let's also connect our UV tiling control to the UV inputs on each node. Okay, so our master material is getting there, but we do still have a good few issues that need ironing out here. One being the fact that we appear to have lost our material preview, whilst another is that oftentimes artists will want to have a more generic roughness control available to them than just our current bitmap only solution, so something controlled either numerically or by colour for instance. Now, whilst we could use solid colour grayscale bitmaps to do that with this setup, that approach would be extremely costly in terms of the time required to tweak and test each roughness change. We also have the problem, if I just save our material here, and then jump back into the main editor, of usability. To show what I mean by that, let's right-click on our master material, create a material instance from it, and then double-click to open that instance up for editing. And as you can see, none of the functionality that we have created up to this point is actually available to us. These all being problems that we will address in the final part of our look at creating a basic master material for our project template in the next exercise. Diving straight into solving the problems that we outlined at the conclusion of our previous exercise then, let's first of all extend the usability of our roughness control by adding the option of altering its settings via a colour value. With our master material open for editing then, let's select the colour node from our tinting system in the base colour block, And then after using the Ctrl and W keys to duplicate, position it with the roughness map node in the graph. Now we didn't duplicate the switch node here because given that it is a parameter already, the duplicate would be tied to the original, and so altering the value on one would affect the other as well, which is obviously not what we want. And so, after dragging from the color node, let's create a new switch for ourselves and set the default value in the color swatch to a darkish grey, so 0.01 in all channels should be good. We can then pipe the roughness maps texture node into the true input on the switch and add the color node to the false, which means that all we need do to complete the roughness control is pipe the switch node into the roughness parameter on the material and then add a comment box to the nodes called roughness control. And that is it. We are done with the roughness section. Well, almost, because we still aren't seeing a preview here of what is going on. And so let's first of all detach our normal node, which, because it currently has no map attached to it, is actually breaking the material. And so if we right click to break the connection, we can add a bitmap to the roughness texture sample node. We will of course need to first of all import that into the project, and so after coming back to the content browser, let's again use the import asset feature to grab both the supplied roughness and normal map files from the extra assets folder in the exercise files download. Once done, we can quickly add the map to our roughness control texture sample node, and then quickly save and test, in order to show that the switch over to using a roughness color control is indeed working. Another problem that we highlighted as needing to be sorted here was the fact that none of the material functionality that we have created up to this point is showing up in any material instance created from this master, a problem that we will now address by essentially turning all of the nodes that we want as controls in the material UI into parameters. First of all then, let's right click on our vector1 node, convert it to a parameter which we will call metallic, and then make sure that its defaults are set to 0. As the metallic setting is typically used in an either on or off state, I will also set the slider min and max values to 0 and 1 respectively. Inside the material expression section, let's highlight the text in the group dropdown, and then type the word reflections, which will essentially create a UI section in our material called reflections, into which we can add other material parameters from the graph if we want. Let's then do the same for the texture sample node that controls the roughness option by right-clicking and converting it to a parameter called roughness map, after which we can again set its UI group via the drop-down list to the reflections heading that we just created. Coming to the switch node for our tint control, which as noted is already a parameter, we can call this color tint on off, seeing as it is a toggle, and then create a group for it called base color. We can do the same thing for the roughness switch, only this time calling it roughness map on off, and then adding it to the reflections group. Following these same basic steps, we now need to create base color map and tint color parameters in the base color group. We need to create a roughness color parameter to be added to the reflections group. And we also need to create a normal map parameter that should go in a normals group. In fact, as we will need to have the normal map node piped into the material by default, I am going to, in its material expression texture-based rollout, search for and add the normal map file that we imported earlier, which we will of course be able to swap out in any instance materials that we create from this master. Finally, we can pipe the normal map into the material if it isn't already. What we can do after saving now is come back to our instance material And note that we now have access to all of the parameters that we have just created, each sitting in their respective rollouts. It is also worth noting that we can of course make our master material even more flexible and functional if we like by adding things like levels controls, blended normal mapping, transparency and translucency features, and so on. As you can already see though, when it comes to template setup, having these types of materials ready to go in our template can potentially give us a huge boost in terms of both productivity and speed. Although not essential to the functioning of the master material that we have added to our template, we just wanted to add this bonus video to the material section to very quickly demonstrate how we could add a little more organization to the layout of our created parameters if we wanted, which in part means taking a look at the sort priority value that each of the inputs we have created comes with. Although the first thing that we need to do here is rectify a mistake that some of you may have already spotted, and that is the fact that our UV tiling control hasn't been exposed for anyone using this master material to take advantage of. And so, with our master material open for editing again, let's right-click on the constant node controlling the UV tiling, convert it to a parameter called, strangely enough, UV tiling, and then add it to a UV control group. Getting back to our original topic though, we have of course already created a semi-organized setup due to our use of group names that create UI sections into which we can place any number of material parameters. To remind ourselves of what I am talking about, let's quickly save our material and come back to the material instance that we created in the previous exercise. If you deleted it before saving, just go ahead and quickly create another one. And we can note in the Details tab that we already have our parameters sorted into usable UI groups, so base color, normals, reflections, and UV control. These group headings being sorted alphabetically. What if we wanted these headings to run in a more specific order though? So let's say UV control, base color, reflections, and then normals. Well, one thing that we could do to achieve this is numerically tag each of the group names. After jumping back into the master material then, let's select our UV control node and assign that to a new 01 UV control group. We can then add all of the base color parameters to a new 02 base color group. And so it goes, with reflections becoming 03 reflections and normals becoming 04 normals. Now I have missed adding the metallic node to the 03 reflections group here, and so let me quickly take care of that. And if we have done everything correctly, we should be able to save, jump back to our material instance, and note that we have successfully reordered the groups in our material UI. Better still is the fact that we can also reorder the various parameters inside a UI group by means of the sort priority option that we mentioned right at the start of this exercise. So for instance, if I go ahead and enable the roughness map option here, you can see that the roughness map control opens above it, which ultimately isn't a particularly big deal, though it would seem more logical for it to open up below, which is something that the sort priority option can do for us. Coming back to the roughness nodes in the master material then, let's select the color node and give it a sort priority of 1. Let's then set the roughness map switch to number 2. And then finally, let's set the map control itself to be number 3. What we get when we save, apply, and come back to our material instance now is a map slot that sits below the roughness map switch once that has been enabled. Whilst working with the material system in Unreal is initially speaking nowhere near as straightforward as working with, say, a V-Ray or Corona material in 3ds Max, once we get used to it, the options that it can open up to us are unlimited. And of course, in terms of customizing a startup template, this system is pretty hard to beat. Having run through the basics of how we might go about building an Unreal template for use on Arch Viz projects, what we want to do in this chapter is run through a similar and yet somewhat different version of the process should we want to use Unreal for product visualization work as well. And so, as we did with our first template, let's go ahead and launch the version of Unreal that we want to work with, only this time picking the automotive and product template from the Unreal project browser window. After then using the next button for a second time, I'm going to go with the no starter content or ray tracing options, though if photographic or photoreal rendering is the most important aspect of a project, then we may want to turn ray tracing on. For now though, let's make certain that we are saving our project to the exercise files and Unreal project folders as product_template, and then hit the Create Project button. Again, depending on our prior use of Unreal, it may take a while for the project to compile at this point. Once done though, we can move on and quickly delete the player start and sun and sky objects, as we won't be needing those particular elements in this instance. We can also drop the floor geometry down to 0 or even -10 on the Z or Z axes in the scene, meaning we can still use it to help bounce some of our light around, but without it interfering visually with any backdrop or background geometry that we may want to import. We could also, of course, make use of the HDRI backdrop actor as seen in the previous chapter in order to place our product inside a very specific lighting and background setting, given that it does, as already noted, incorporate a ground plane element for use as a shadow catcher. In this instance though, I am wanting to set the template up using both a basic product stand-in and a ready-made studio backdrop that has been created in 3ds Max, and so if you already have a studio type setup that will be used in most, if not all of your product visualization pieces, then placing it into the level at this point would probably be a good idea. If you tend to work with continually changing backdrops on a project though, then importing them as and when needed may be a better idea, as this will help keep the template as fast, easy to use and flexible as possible. The same points regarding folder structure and naming conventions as noted in the previous chapter will still apply here, of course, though rather than repeating a process that you have already seen, we can assume that those things have already been taken care of, and in this video focus instead on the differences in this particular setup. To transfer the geometry files from 3ds Max, I have used Datasmith as the export-import option of choice, and so we will want to go ahead and add a Datasmith folder to the content browser into which we can place our assets. Though if we were using the FBX option, then our default static mesh folder would probably work just as well. As a quick side note, if 3ds Max happens to be your DCC application of choice to work with Unreal, then you may want to check out my 3ds Max to Unreal Engine workflow and troubleshooting course as found here in the LinkedIn Learning Library, given that it covers quite a few of the possible workflows, glitches and niggles that we can run into when transferring data between Max and Unreal, along of course with also showing some of the potential fixes. Okay, so after creating our Datasmith folder, we can next click on the big Datasmith button found in the Unreal UI and import the already provided Datasmith file that can be found in the Exercise Files, Extra Assets and Datasmith folders. After electing to add this to the Datasmith folder that we just created, in the Datasmith imports dialog that now pops up, we can leave most of the settings at default, except for in the advanced mesh settings rollout, we want to switch the min and max light map resolutions over to 512 and 2048 respectively, given that a typical product shot setup should be a pretty simple scene so far as Unreal is concerned, and so not be too taxing on its computing resources. I also want to make sure that the Create Light Map UVs option is unchecked here, simply because all of the objects being imported have already had a second UV channel for light maps added to them. After that, we can go ahead and hit the import button. Once done, we should be able to jump into viewing the scene from the master camera that was set up in 3ds Max and V-Ray. And if we then switch our viewport over to unlit mode, simply because we currently have no light sources in the scene, we should be able to select the backdrop, movie camera, and product stand objects that we have just imported. Now, dependent on the way in which we prefer to work, there are a few options available as to what we might move on to next in terms of setting up the basic product template that we need. Personally speaking, as I would prefer to get a basic lighting setup in place before moving on to other scene elements, we will go ahead and take a look in the next exercise at setting up a standard and yet very flexible 3-point lighting system that can again be configured in a bunch of ways according to the types of product that we typically work with. Given that working in the dark isn't, typically speaking, a pleasant experience in many areas of life, the very first thing that I tend to do once I have the basic geometry set up in any kind of 3D scene is add some light by which I can work. In this template building exercise though, we want to take that idea one step further and build a flexible 3-point lighting setup that could actually be used in many production situations, starting first of all with the placement of our key light. Coming to the light section of the Place Actors tab then, let's left click and drag in order to drop a rectangle light into our scene. Now, depending on your lighting preferences, we could just as easily use a point or spotlight here, given that the Unreal versions of both of these are flexible and powerful enough to be used on many types of product shots. As we are deliberately setting this template up to be as photographic in nature as possible though, we're going to stick with an area light, as this will allow us to hopefully create something of a softbox type effect in our shots should we want or need to. Again, the settings that we use in a template will very much depend on the type of products that we are visualizing, but to set up the key light for this vintage movie camera, I'm going to come to the transform section of the details tab, and with the light still selected, punch in location values of 17.5, 63 and 60, along with rotational settings of 0, 300 and 275. Which, if we jump into lit mode in our viewport now, should give us a key light that produces angled shadows coming across the face of the camera from the lens assembly. Let's also tweak just a few of the light settings that we have here, simply because the setup of these will again depend upon the type of assets that we will be bringing into the scene, and of course on the exposure settings that we want to use, whether this be on our cameras or in the post-process volume. To that end, let's go ahead and open up the advanced rollout then, and make the switch from using candelas as the lighting unit of choice to lumens, simply because we can then make an easy intensity correlation between the lights that we have set up here in Unreal and any that we may have been using in our 3ds Max and V-Ray scene. In this instance, I'm going to have the key light output a value of 300 lumens, which gives us a radiant power output of about 0.45 watts. As I want to create a somewhat contrasty looking image, let's set the width and height values for our light to 7 and 5 centimeters respectively, and then also add a barn door angle of about 25. Now, of course, with no exposure set up as of yet, things are looking very overbright, and so if you want to get a viewport only preview of the final exposure level that I will be aiming for, then you can quickly come to the View Mode menu, and in the exposure section, uncheck the Game Settings option, and then set the exposure value to around about 5 or 6. Now, we may want to come back and tweak both these and other settings on our light a little later in the chapter, but for now, let's leave our key set just as it is and move on to adding the fill lights that we also want. Although, actually, let's just make a final tweak here by renaming the light in the world outliner to light_key. To add our fill lights and complete the basic 3-point light setup that we want, let's drag and drop 2 more rectangular lights into the scene, and then immediately rename those to light_right fill and light_left fill. In terms of placement, with the right fill selected, let's come to the Details tab and enter location values of 135, 90 and 30, and for the rotation settings 0, 0 and 200. We will again switch over to using lumens as the unit of measurement and set the intensity value to 150 with width and height settings of 40 by 40 centimeters. If we then quickly hide the key light in the outliner, we can easily see the effect that this one light is currently having on our scene. With the left side fill selected next, we can run through a very similar process, only this time setting location values of -165, 125 and 50, along with rotation of 0, 0 and 320. After switching to lumens, let's again use an intensity value of 150, and again set the width and height values for the rectangle to 40 by 40 centimeters, which, with the other 2 lights enabled or unhidden in the scene, gives us a pretty decent generic setup for a solid product type shot. If we work with different product types, of course, then tweaks will need to be made according to the specific lighting needs of that product. For example, translucent or transparent objects may benefit from having a fill or even a key light that comes from behind the object in order to show off its material properties. The main principle that we want to take away from this video, though, is the fact that we will need to think carefully about the type of work we mostly produce and then create a basic light setup for that, but without getting caught up in any of the details at this point in the process. As it is very much connected to lighting, the final thing that I will do here is come to the Visual Effects section of the Place Actors tab, and then drag a reflection capture sphere into the scene, placing it just in front of our product geometry, so location values of 0, 60 and 20. Now this won't always be needed, of course, but if we have areas of a reflective product that has, say, deep recesses on it, then this reflection capture probe can just help the reflections display a little more accurately. And with that, we can leave our lighting as it is for now and move on to adding some extra cameras into the scene, just in case we want some shot variety. Though if we wanted to get a better feel for how the lighting that we have created here does look, then we could set the lighting build options to production and then go ahead and build the scene lighting. As we will be tweaking our light mask GI settings a little later on in the chapter, though, I am just going to leave things as they are for now and move quickly on to the next exercise. When it comes to creating a project template that can be used with products as opposed to an architectural type workflow, there are a whole bunch of questions that it would be good to both ask and then answer as we work to set it up. In this video, for example, we are once again going to be setting up cameras in the scene, and so questions such as what range of focal lengths best show off the type of products that we work with, what camera positions and placements tend to work well for those, and also how many cameras are typically needed in a scene that we shoot. Now, of course, earlier in the course, we created a camera setup that allowed the user to walk around inside the level, and so placing just one camera inside of a sequence was more than enough there. As we are now setting up for a product shot, however, having more than one camera available right from the start may well be beneficial. And so in this particular version of our template, we will set up 4 different cameras that can be used to get us up and running via this generic product template. As we already have the master camera in the scene from 3ds Max and V-Ray and a cine camera actor from the Unreal template that we started with, all we need to do here is come over to the cinematic section of the Place Actors panel and then add 2 more cine camera actors from the list by means of a drag and drop operation. Now, the default positioning that we choose for these cameras in the template will again depend on the products that we typically shoot, the studio background or backdrop that we typically use, and also the feel or the mood that we are going for in our shots. All of which means that we're not going to spend too much time on being too specific here, as I feel that this is one of the things, along with the lighting setup, that an artist using this template will be most likely to change. For the purpose of giving some context to the exercises in this chapter though, let's assume that what we are going to be doing is creating a series of shots with a variety of products for use in a vintage camera catalogue, simply because of the asset that we are already using, with each product needing to be shot from 4 different angles. As we already have the first of those 4 angles, given that the master cam shot we already see in the scene gives us a nice clear view of any product that gets placed on the stand, we can call that a keeper, and instead select one of the other cine camera actors in the outliner, renaming it to cam_alt_3/4. And then from inside the Unreal viewport, we can jump into viewing the scene through that particular camera view. In terms of any changes that we want to make here, let's, in the film back rollout found in the Details tab, set the camera's sensor width and height values to 36, essentially giving us an image aspect of 1 and thereby a square image as per our master camera. After which we can set a focal length of 40 and aperture of 22, just to be sure that no depth of field effect is showing up for now. We can then frame up on our product by using location settings for the camera of 27, 60 and 18.5, as well as rotation values of 0, 2 and -142. For our third camera setup, let's again select one of the cine camera actors in the scene, this time calling it cam_head-on. And then after setting sensor and focal length values of 36 and 60mm respectively, set location values of 0.7, 70 and 17, along with rotation values of 0, 2 and -90. After which we can get a larger view of what the camera is seeing by jumping into it in the viewport, which shows that we again need to temporarily use an aperture setting of 22 in order to avoid getting any noticeable depth of field in the shot. Finally, let's rename our fourth camera to cam_overhead, and after altering its sensor values to 36 by 36 and its focal length to 100, we can preempt the need to use an aperture setting of 22 and quickly set location values of 0.5, 32 and 123, along with rotation values of -90, -90 and 0. We can again check how this is working in the viewport if we like, and as easily as that, we now have our default 4-camera setup in the template and ready to work with. Having added a variety of camera shots or angles to our Product Viz template, the next thing that I want to take a look at here is how we might go about tweaking the settings on those cameras to better serve the setup that I have chosen. Rather than repeating the same basic steps 4 times over though, what we will do is focus on tweaking just the master camera in this exercise, whilst keeping in mind that similar types of adjustments can be made to any camera that we have placed in the scene. First of all then, let's begin with the fact that during the export-import process, the master camera itself hasn't framed up in quite the way that I had it looking in 3ds Max and V-Ray, and so after selecting it in the World Outliner, let's quickly rectify things by coming to the Details tab and setting the current focal length value to 45. Whenever photographing an object the size of our vintage camera here, it is probably going to be best if we keep our aperture set to a fairly small value, so somewhere between the 1.4 and 4.0 range, assuming that we are wanting to stick with using standard photographic settings in our work, that is. Though this is of course by no means absolutely necessary. This range of settings being particularly useful if we are wanting to add something like a depth of field effect to our setup, which is exactly what we will do here. And so, after opening up the Focus Settings drop-down in the Details tab, we can switch the default focus method over to tracking if that suits our shot, this letting us lock focus on a very specific object in the scene via the Actor 2 Track drop-down. We could also, as I want to retain full manual control in this instance, select the manual option instead, set the current aperture value to 4, and then after altering the focus distance to about 40 centimeters, we should see our background blur out whilst the product stays clearly in focus. Now, if you want to try altering these settings for all of the cameras in the scene, perhaps in order to experiment or to give a consistent feel to each of the shots being produced, then now might be the time to pause this video in order to go ahead and do that. Now, perhaps the natural thing to do at this point would be to work next on our exposure settings, bearing in mind that the quick viewport exposure value tweak that we made earlier is a viewport only adjustment that wouldn't show up in any kind of playable mode for the level, although it would show up in any high resolution screenshots that we take using the viewport options menu. With that in mind then, let's turn the game settings option back on in the view mode menu. And then in the post-process lens and exposure rollouts for our master camera, we can either turn off the metering mode control, and then after turning on the min and max EV100 controls, set the exposure value to a fixed setting of 6 or 7 for both, seeing as we won't want any exposure variations taking place if the camera moves. We could also just reset those options and instead turn on exposure compensation, setting a value of -2 in this instance. Again though, do feel free to experiment with other values or other options if you are using this course to set up a basic starter template for your actual production work. Finally, for this exercise, let's take a look at the white balance option, which is really a setting that should only be altered once we have our final lighting in the scene. And whilst the whole subject of colour balance in an image is one that we could go quite deep on, in this particular instance we're going to just make certain first of all that our scene lights aren't using different colour temperature settings from one another, simply because this will make it easier for us to get the in-camera white balance setup that we want. Now, technically speaking, this part of the setup could have been handled as we added the lights into the scene. But given that it is very much tied to the white balancing of our cameras, it just seemed more sensible in my mind to take a look at it in this section. After selecting the key light in the scene then, let's come to the light rollout in the Details tab, and note that we do have a temperature option that we can enable, with the default being set to a Kelvin temperature value of 6500. This essentially being a pure white daylight balance, which is not to be confused, of course, with a standard daylight temperature balance of 5500 degrees Kelvin, which has a slightly warmer daylight tone. Now again, whilst we could just as easily have used the default colour option on the lights if we wanted, use of the Kelvin temperature scale in lighting is a standard photographic cinematic convention that it makes sense for us to use, seeing as it is available. Let's go ahead and complete that check for all of the lights in our scene then, bearing in mind that if we already know that we will be required to use different colour temperature settings on our lights, then we might as well go ahead and set that up right now if we want to. Once done, from inside the post-process lens colour grading controls on our camera, after reselecting it if necessary of course, we can open up the white balance sub-rollout, and now adjust the white balance of our camera in relation to the already balanced temperature settings of the lights in the scene. One point to keep in mind here being that when the temperature value that we use in our white balance control exactly matches the one found on our light objects, then all emitted light in the scene will be pure white. Whereas if we use a value that is higher than the lights, then the lights will appear to warm up or become more orangey in tone. Whilst conversely, if the value is lowered, then we cool down or add a blue cast to our lighting. As white light is a perfect starting place for a template level though, let's leave this set at 6500 and move on to once again adding a sequence to our level in case we want to use animated cameras in our product work. Much as with the architectural template that we built in the previous chapter, there is the distinct possibility when setting up a product template that we will want to show said product off via some well thought out camera animations. And so let's take the time in this exercise to set up a camera sequence that contains all 4 of our scene cameras, and then maybe even add some basic animation to one of them just as a starting or reference point. To begin with then, let's create a camsec folder inside the content folder, this being one of the standard folders outlined in the previous chapter. And then after right-clicking in some empty space inside there, from inside the animation flyout, we can again choose the level sequence option, which I will very unimaginatively name PS_S1 for product shot sequence 1. With a camera selected in the outliner now, I will opt for the master cam first of all. We can double click to enter the sequence, and then from the top of the UI via the track button, add the master cam actor, which as you can clearly see adds the camera and its options to the sequence just as it did before. Let's repeat the process for the other cameras that we have in the level then, until we have a list that looks like this. Now at this point we can either save the template as is so that we can set up our animations in a blank scene if wanted, or we can also, as I will do here, go ahead and add some basic animation to the cameras just as a starting point. That having been said though, for the sake of demonstration purposes, I am only going to complete the process using a slow push in with our master cam, though of course adding animations to the other 3 cameras would follow exactly the same steps. Coming to the master cam track in the sequencer then, let's click to expand the transform options if needed, and then place a keyframe at the current and so default location. After which we can move along the timeline to around about frame 120, and then back in the 3D view with the master cam selected and framed up in the viewport, we can make sure that we are using local object space for the transform gizmo, and then with snapping disabled, push our camera into the product ever so slightly, and then of course add another set of keyframes in the sequencer. If we then jump into the camera view in the viewport and use the controls in the sequencer to play the animation, so long as we still have the camera selected in the scene, we should see our viewport update as we play the animation. At the moment, the camera's animation does have ease in and ease out applied to the keyframes, which, although very useful in many animation situations, isn't something that I really want for this base animation. And so, in the sequencer, let's drag a marquee selection around the keyframes that we have, right-click on just one group of them, and then set them all to linear interpolation. This typically giving us the ability to cut between camera animations and have everything look smooth and natural, with no speeding up or slowing down creating motion discrepancies. Now clearly we could do quite a bit here to make this animation more usable, such as altering the depth of field effect and even framing up on the camera a little more centrally if desired. As you can see already though, taking the time to both set up the cameras in the scene and then maybe even add some basic animations to them, probably more refined and complex than the one that we see here, well, this does have the potential to save us quite a bit of time that we can then use to focus more on the production value of our work rather than just its initial setup. To finish up our product template then, let's take a look in the next and final exercise for the course at one example of a high quality light mask setup that could also be used here. Typically speaking, one of the things that content creators using Unreal need to be mindful of is the performance of the engine once an application or game gets into the end user's hands. Fortunately for us in this situation though, Product Viz projects don't tend to have an end user, just a creating artist who will work with our template scene in order to produce the final shots, be they still or animated. What we can do as a final step in creating our Product Viz template then is add some high quality light mask settings to the proceedings that should then require only minimal tweaking in order to better suit the type of product currently being worked with. Coming to the World Settings tab, we can open up the light mask settings rollout, and after resetting everything back to default, we can set both light bounce options to 6, which means that even if we should have a product with lots of detailing in it, the light being thrown around in the scene should easily be able to make that stand out for us. The quality and smoothness settings, as noted previously, should always be adjusted in tandem, and so I will increase the quality to 1.2, but at the same time drop the smoothness down to 0.85, just to stop Unreal correcting for the extra lighting detail that we're trying to add in. Now these settings will naturally increase our light build times by quite a bit, and so when perhaps doing test renders to check on composition or camera animations and such, we will probably want to use either the preview or medium settings from the lighting quality flyout so as to not ultimately end up wasting the time that we have saved by creating the template scene in the first place. Good to keep in mind then that we are putting these lighting settings in place as a means of avoiding having to do all of this work each and every time we create a new project. Using such quick settings then, whenever we have to create a test build, just makes sense. I do want to add just one more detail to this particular version of the product template that I think will help improve the overall quality that the light build gives us, this being to add an ambient occlusion effect via the post-process volume. Now we do already have one of those in the scene thanks to it being included in the blank template that we started with. As this has proven to be a little bit wonky to work with for me, I'm going to go ahead and delete that in this instance. And then after coming to the volume section of the Place Actors UI, drag a new one into the scene, and then quickly make sure that it is both sitting at the world origin and that in the post-process volume settings rollout, the unbounded option is checked. This just ensuring that everything in our scene is definitely included in the volume's calculations. Next, in the rendering features rollout, after making sure that we are inside the ambient occlusion section, we can turn on both the intensity and radius controls. We can set intensity to a value of 0.8 and the radius to 40, and then check what these settings are doing by performing a lighting build using the production setting, which, depending on the power of your machine, could take quite some time, so do feel free to use a lesser option if needed. And indeed, once we take a look at the results that we are currently getting, we could be forgiven for thinking that we have already done just that, seeing as the finished quality is less than stellar. There is, however, one more feature on our lights that we need to enable in order to have them behave in a more realistic way, given that by default the Unreal rectangular light comes into a scene as a stationary and not static light. Which means, if I just go ahead and select the key light, that we will really want to scroll down to the light mask settings and enable the Use Area Shadows for Stationary Lights option, remembering to do so, of course, for the other two lights in the scene as well. If we go ahead now and run through the build process one last time, what we get is a much more acceptable end result. Beyond a shadow of a doubt, the best way to continue growing as a visualization professional using Unreal is to do as much work with the engine as possible. So production work where that is available, personal projects as time allows, and definitely by working along with training courses such as this, so as to be able to add new skills and new know-how to our existing storehouse. To help with that, the LinkedIn Learning Library houses some 40 courses that cover a wide range of Unreal subjects by authors such as myself, George Maestri, Craig Barr, Simon Manning, and Joel Bradley, amongst others. Don't forget also that there is a wealth of training material available from Epic Games themselves over at the UnrealEngine.com website. And if you have already or are planning at some point to make the jump to Unreal Engine 5, then do be sure to keep your eye out next year for my architectural visualization with Unreal Engine 5 book from Pact Publishing. Thanks ever so much for taking the time to work through this course with me, and as always, do feel free to get in touch through any of the means noted on the splash screen. This being especially good if we can connect together via the LinkedIn platform. Until next time then, this is Brian Bradley saying take care and bye for now.